নামি দামি কোম্পানি স্ট্যান্ডার্ড কোয়ালিটি টেক্সটাইল, স্টিল এবং নাইলন প্লাস্টিকে সংসারের অতি প্রয়োজনীয় বিভিন্ন সামগ্রী যেগুলি আপনাদের সংসারে নিত্য প্রয়োজন লাগবেই। সমস্ত জিনিস লোহার বাড়িতে তাই বলছিলাম প্রচার গাড়ি এখন আপনার বাড়ির সামনে আপনার জন্য দাঁড়িয়ে আছে। প্রচার গাড়িকে লক্ষ্য করে মাসিমা আসুন, দিদি ভাই আসুন, আসুন দেখুন দেখুন।
স্টার্ট করবো, কেউ আসবে? হ্যালো,
হ্যাঁ স্যার, স্টার্ট করুন।
আচ্ছা, লাস্ট দিন ল্যাব কি হয়েছিল আমাকে একটু বলবে তোমরা? কি হয়েছিল?
এসকিউএল কোয়েরিজ করিয়েছিল।
মানে কি কি করেছিল, কটা টপিক করেছিল?
মানে ফার্স্টে স্টুডেন্ট ডেটা একটা টেবিল বানালাম, দিয়ে তো ওখানে স্টুডেন্ট ডেটা ডেটাবেসের মধ্যে ইনক্লুড করলাম রোল নাম্বার, প্রাইমারি কি দিয়ে, এটুকুই হয়েছিল।
কোনো কোয়েরি রান করো না?
এইটুকুই করেছিলাম, মানে টেবিল ক্রিয়েট করে তার মধ্যে স্টুডেন্ট টেবিল ক্রিয়েট করে তার মধ্যে স্টুডেন্ট ইনফরমেশন, হ্যাঁ, ডেটা ইনসার্টেশন, এটুকুই।
আর কোনো স্কুল কোয়েরি রান করবে?
না,
একটাই টেবিল হয়েছিল আর একটাই ডেটা ইন্ডাকশন আর ডেটা ইনসার্ট হয়েছিল।
হ্যাঁ, একটাই হয়েছিল।
আচ্ছা, today we will the three scheme architecture is already discussed, right? Three scheme architecture করেছো, এগুলো পড়ানো হয়েছিল। অক্ষয় কোথায়? অক্ষয়কে তুমি জয়েন করে কি কোথায় গেলে?
হ্যাঁ স্যার বলুন। হ্যালো,
করেছিল আগের দিন যেগুলো পড়ানো হয়েছিল? হ্যালো,
হ্যাঁ স্যার বলুন।
বলছি আগের দিনগুলো পড়ানো শুরু করেছো?
পড়াটা, হ্যাঁ ওই অল্প একটু দেখেছিলাম জাস্ট।
Okay. So today we will start the database model. Right. So what are the different database model we use? Means lot of different models. A lot of models are there. Right. But some of these models are used very frequently, and most of the famous and most of the widely used model is the relational model, right? That already we know. So can anyone tell me that what is the meaning of data model? Means what is data model? তো বলতে পারবে data মডেলটা কি? হ্যালো, কেউ বলতে পারবে what is data model?
স্যার ডেটা মডেলটা হচ্ছে ওই মানে ডেটাবেসের লজিক্যাল স্ট্রাকচারটা কি করে মডেল করা হয়েছে সেটাকে বোঝানোর জন্য ডেটা মডেলটা ইউজ হয়।
Or physical structure?
ইয়েস স্যার।
Physical structure টা?
ফিজিক্যাল স্ট্রাকচার, লজিক্যাল স্ট্রাকচারটা বোঝানোর জন্য ইউজ হয় ওটা।
অন্বেষণ?
ডেটাবেসে যে ফিজিক্যাল স্ট্রাকচার গুলো আমরা ক্রিয়েট করি সেটা যেভাবে আমরা প্রেজেন্ট করি সেটা ডেটাবেস ডেটা মডেল।
আমাকে জিজ্ঞেস করছো?
হ্যাঁ বলছি সেটা কি ডেটাবেস মডেল।
না, physical structure directly implement করা যায় না। Yes, data model is the by using the data model. Data model is basically um, organizing. Is it is actually depicting how the data is organized. That's how you are organizing all the data, right? What type of data you are dealing with, right? What are the constraint you are using, right? Means it is basically giving you the conceptual uh, model. Basically this is giving the conceptual view of the uh, database. Similarly, it is giving you the physical view of the data model also, a physical view of the database also, right? Means suppose you are the architecture, so means before uh, developing a building, before starting to develop a building, the architect are doing the sketch of the building, right? So data model is like that. It is the uh, sketch how and where the data will be stored and what type of data will store, and what type of data you will deal with. So this is the data model. Is it clear? Means it is giving you the data descriptions, it is giving the uh, different constraints, it is giving the different semantics, right? Is it okay?
Yes sir.
Yeah. So there are here I have given you two pictures, right? Simultaneously here I have given you the two pictures where um, the data models are categorized into three uh, types: conceptual data model, representational data model, and physical data model. Right? The right hand side also there are another categorization is there, which is object based data models, record based data models, and physical data models. Right? These two categorizations are same. These two categorizations are same. Right? This year and object oriented model are basically under the conceptual data model. Right? This relation model, network model, hierarchical model, these are actually the representational data model, right? And under the representational data models. Physical data models, both are same. Here the physical data models is there, here also the physical data model is there. So you can categorize either in this way or you can categorize in this way also, right? So I'm coming to these three types. So conceptual data model, representational data model, and physical data model, right? So what the conceptual data model? It is describing uh, the database that it is used to understand the need or the requirements of the database. Right? Means when suppose you want to develop a database, so what are the data are actually needed, right? And what should be the constraints? So it describes all these things. Right? What are the requirements are also required for to make the model. So this conceptual data model is basically giving you all the details of the data, what are required, right? How the data are related with each other. These things is also important. This is also analyzing here, right? Different constraints are also analyzing here, right? Means before the start of the database, means before the starting of designing the database by the designer, you have to take the help of the conceptual data model, right? And year model, object oriented model, these are the examples of this conceptual data model, right? This year model, object oriented model, so these are the examples of the conceptual data models. Okay. Representational data model is what? Here it is actually representing the database, right? If you think about the table, if you consider the relational model, we know that we are representing the data in the tabular form, right? So this is the representation, this is the logical part of the database, means how the data are representing. So by this data model you can uh, represent the data, right? Represent the physical structure of the database, how the data is actually organized, how one table is if you consider the relational table, uh, then how one relation is in relationship with another relationship. In network model also, how one node is related with another node. Each node consists of what type of data, right? In hierarchical model also, how the one node is connected with another node. So this is the representational data models. So this representative data model is basically the design part of the database, right? It is the design part of the database, that how the data you are designing based on the conceptual data model. Because in conceptual data models you have gathered all the requirements, you have gathered the different types of data, right? You have your knowledge, you get the you gather the knowledge of different constraints in conceptual model. So in representational data model we will apply all these things, right? So this is the relational data model, and you know that the relational model is a very famous or very popular data model that, and also you also use the relation data models. Okay, it's clear. Any question?
No, sir.
Okay. Last one, this is a physical data model, and physical data model is basically the how all the data are stored in the storage media, means how the data are stored in the memory. Right? It can be the primary memory, it can be the, basically it is storing in the secondary memory. So how the data are stored in the secondary memory, it can be stored in the form of a file, it can be stored in the form of a record, it can be stored in the stored in either any type of data structure. It can be stored in like an array, it can be stored like a queue, uh, then stack, anything, right? So this is the physical data model. And I don't know you're familiar with this or not. UML, by using the UML, means unified modeling language, you can define or you can represent this physical data model also, right? So this is not in our syllabus, this is not our part. Physical data model, UML basically is a part of the software engineering, so we will not deal with these things. So here we will consider these two, that object based models and the record based models, or the representational data models, right? So it's very popular, it's a very uh, popular database model that already we are familiar with, right? This is the entity relationship model. So, and one thing is that this year model, and in the previous picture, if you see that this conceptual model or the object based data models, right? What is the meaning of the object based data models? Uh, Object means that we already know that these are the real life entities. Object means what? Which have real life existence. Anything around you, whatever you will think, all are object, right? From your book to your hair clip to everything is the object. So object based model means what? That that object should have some attributes, right? When you are considering a material or an entity as an object, obviously it will have some attributes, right? Suppose you think about a piece of paper, or if you think about any entity, so every entity has some unique attributes, right? So we are representing each object, each entity with respect to its attributes, right? So object-based model means, object-based data model means, here we are only dealing with the different objects and their attributes, and how the one object is in relationship with other objects, right? Here we are not bothered about the type of the data. Here we are not bothered about the size of the data, right? Only we are bothered about the object, right? Object, its attribute, and the relationship among the objects, right? So these object based data models are what? There are two types. One is year model, and one is the object oriented model. Okay, it is very already you are familiar with this year model. So here we have the entities, right, which are represented by the rectangular boxes, and the attributes are there, which we are representing as a oval around it, like this. Right? Relationship basically we are representing in the form of line. There are different types of relationships are there. One to one, one to many. One to one means what? Is if one object is in relationship with another object. then it is the one-to-one relationship. Right? Like, can you give an example of one-to-one relationship?
Student teacher.
No, this is not one-to-one. A student can have many teachers. A teacher can have many students. This is not one-to-one. Anything else? Anything else? Suppose you uh, all of you are all of us we are using the UPI account, right? All of we have the UPI account. So against one mobile number, you can activate one UPI account. Is it clear? Or simply suppose you have the um, uh, Amazon Prime account, right? Or the Netflix account. So against one mobile number, you can activate one account only. Is it clear? So it can be the one-to-one relationship. Means with one mobile number, you can activate one account. Clear? Any question? Okay, no question. One to many means a student teacher or teachers. One to many means a teacher student. One teacher can teach many students. Right? Many to one. Right? Many to one also the same thing that many students can be under one teacher like that. Many to many is also there. So these are the relationship means how the objects are in relationship with another objects. So by this way you can uh, differentiate different types of relationship. This is the second one. This is the object oriented model, and you are familiar with this term also, that object oriented, right? Means object based and object oriented both are different thing. Object based in object oriented programming, in object oriented model, the inheritance is supported here. Inheritance means that what is the meaning of the inheritance? Do you know that? Means, can you remember this? Hmm? Can you remember the inheritance property? Inheritance property means if object oriented means obviously you know that here the class concept will come, right? Here the objects are communicating with each other, but each object are of different class type, right? Here we are basically making a group. Here we are basically making the group of similar objects, right? Which is known as the class. And what is the hello? Can you hear my voice? Hello? Can you hear my
Yes,
voice?
sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So in object-oriented model means the object-based model means if you know about the object-based, uh, you know about the class, object, data encapsulation, right? Data wrapping. So these are the features of the object-based models. But when it is the object-oriented, then the inheritance, polymorphism, these properties are adding with this dynamic binding, right? So this is the programming part, but Simply, when here the object-oriented feature is included, first thing which is included, this is the inheritance. What is the inheritance? Inheritance is nothing but that if you want to inherit the property of one class into the another class, this is the object-oriented features, right? This is one of the feature of binding the different classes with each other, or this is features by which the different objects are related with each other. So here, obviously, in object-oriented model, if you remember that here you can see that it is in the class form where the data and functions, the methods are combined with each other in the form of a class. Right? In a class, the different data and the methods which will access this data. So they are in the form which is creating a class. There is another class which is employee. So this employee is what? Employee is the person. Means this employee is another class whose parent class is the person class. Right? So here one class is attached with another class. And this employee is where? This employee is here as a child class. And the person is what? The parent class. Similarly, the objects are also related to each other. So if this is the object which is known as a John, his name is John, address is this. Similarly, employee has the object, and here also the different values are there of this data. There is another object which is Matthew, right, which is taking the different values. So this is the object-oriented model. And one more thing, one more drawback was there of relational model, that in relational model, if you want to insert the audio file or video file or the image file, so the size of the database becoming so large, right? There is the option, there is a data type, that BLOB, a binary file. There is one data type is there, but if you use that data type to insert the audio file or the video file or the, then the database size is so large that it is uh, not fruitful to use the database. It is not, it is consuming lot of memory, lot of time to execute the queries. So to store all these audio files or the video files or the image files, this object oriented data models are used, because here the link is used, right? If you remember the C++ program or the Java program, you can see that here it is very useful to link all the objects, to link the object with the class, right? It's a very easy way by which you can link all these objects or all the classes with each other, right? So the advantage is what, that you can reuse the attributes and functionalities. This is the inheritance, right? It reduces the cost of maintaining the same data multiple times. So these are the features of the advantage. But still it has the disadvantages. That's why the relational model is so popular, because it is not widely developed and complete to use in the database system. Means still some now a lot of developments are there. And there are some databases managements, DBMS are there, which are using these object-oriented models, but it is not completely, they are not completely successful to use the object-oriented model fully. That's why the relational model is still a popular one. Right? Because you can remember one thing, that object-oriented is a concept, it is an approach to solve the problem. Right? This object-oriented is not a technology. When you are learning that object-oriented OOPS concept, so we are just implementing this concept. So this is not a technology, right? So that's why it fails to put in the database management system. Okay. There is another model. This is the representational data models, or the record based models. This is the hierarchical model, where it's a tree like structure where there is the root node, and from this root node the different child nodes are there. So this is just go through this one, right? The data is organized into two-layer structure, and different relationships are there. That one to many relationship is, this is one to many relationship. This is also one to many relationship. So this model like this are forming the hierarchy. Network model is there. It is here the everything is it like a graph. Means if you remember the structure, the data structure, so it's look like a graph, right? Here also the data is related with another, one node is related with another nodes, and it is the one-to-many relationship, right? There is one parent, the root parent, and obviously that by this way we can represent the data also, right? But most popular, widely used model is this relational model, where the data are stored in the tabular form, which is known as the relations. Each relations has a different attributes, right? This is one relation, this is another relation, this is another relation, right? And each relation has different attributes. This is the student ID, name, age. So these are the attributes, and these are the value of this attribute. And each row is known as the tuple. Each row is known as the tuple, and it is recommended that each row should be uniquely identified. Each row should be uniquely identifiable, and that's why we are using the primary key, right? So this is the relational model. So it's clear up to this? Is it clear?
Yes, sir. Clear.
Hmm? Hello?
Clear.
Okay.
Hi, hello, sir.
Hmm.
Clear.
Okay. বাকিদের ঠিক আছে তো? ঠিক আছে। অন্বেষা, জয়শ্রী। ঠিক আছে?
Yes, sir.
Okay. Okay. This thing, this is one of the another important part. This is the data independence, right? And already we know that two that type of data independence over there. There's one is the physical level data independence, and one is the logical level data independence. Right? Data independence is nothing but it is the data abstraction. This is the data abstraction, right? What is the data abstraction? What is the meaning of the abstraction? That the complex, what are the complex data structure, what are the complex part of a database, this is totally hidden from the user, or you know about the view, right? You know about the different view, that all users does not need to know the whole database, right? So that's why the view is uh, used, or the view is set by the DB or DA. Right? Think about a very simple example I am giving. That think about a car, right? So suppose you want to learn driving, right? So when you are studying to learn the driving, so only you need to know that how the accelerator is working, how the steering is working, how to implement the brake, and how to run the car safely uh, on the road, or right, to check the mirrors. Uh, so these things you need to know when you are learning driving, right? You don't need to know the internal structure of the car, that how the engine is working, how the oil is using to run your car, right? How the internal part or how the all these things are working. So that is not compulsory to know to learn driving to learning driving, right? So that complex part is totally hidden from you, and this is not mandatory for you. So this is the abstraction. Similarly, in data abstraction, in database, the data abstraction is also used here, so that the whole database is not representing as a complex one to everyone. So to make it very simple, to make it efficient, and to make it relevant, the total abstraction the part is the view is used to restrict all this complex part. So the main purpose of data abstraction is achieving data independence. Right? So data independence is one of another thing which is held for the data abstraction. And we say there are two types of data abstractions here. One is the physical level data abstractions, another one is data independence or data abstractions, another one is the logical level. Already we know about the schemas, right? We have three schema: physical schema, right? Conceptual schema, and the another one is what? Physical schema, logical schema, and what are the schemas? There are three types of schemas, right? Akshay, Shivam, Anusha.
Physical schema, logical schema, and view schema.
Yeah, physical schema, logical schema, and external schema or view schema. So data independent, physical level data independence means it is the characteristics where you can modify the physical schema without any change in the logical schema. Physical level in data independence is what? Changing the physical schema without any change in the logical schema. Right? Means think about the your example. Suppose you are using the array for storing all the data in a physical schema, right? And now you are using the SQL for storing all the data. Like you are using the SQL 10G, sorry, Oracle 10G to make the tables, to insert the data and everything. If you change the array to the stack or queue, will it hamper to your tables? Hmm? Will it hamper all the tables what you have created by using the Oracle 10G? Can you understand my question? ধরো তুমি ওরাকল 10G ইউজ করছো, তুমি ডিফারেন্ট টেবিলস ক্রিয়েট করেছো, ডেটা ইনসার্ট করেছো, সবকিছু করেছো। ধরো ওরা অ্যারে ইউজ করতো এতদিন ধরে ডেটাগুলোকে স্টোর করার জন্য ফিজিক্যাল স্কিম। ওরা এখন চাইছে যে আমরা কিউ ইউজ করব বা স্ট্যাক ইউজ করব। আর দেন তুমি যে এতদিন ধরে যে কাজগুলো করেছো, যে টেবিলগুলো সেট করেছো, will these tables, will that conceptual schema hamper hamper কি হবে, ডিলিট হয়ে যাবে?
না স্যার, স্টোরি থাকবে কিন্তু চেঞ্জ হবে।
কি চেঞ্জ হবে? টেবিলগুলো চেঞ্জ হয়ে
মানে
যাবে?
স্ট্রাকচারটা যেটা আমি, না ডেটা না, ডেটাটাতে তো স্টোরি আছে, আমি শুধু যেটা আমি কিউতে আমি যদি স্ট্যাক প্রথমে ছিল অ্যারেতে, অ্যারের বদলে আমি স্ট্যাকে করব বা কিউতে করব, ডেটাগুলো চেঞ্জ কেন হবে, শুধু স্ট্রাকচারটা চেঞ্জ হবে।
কোথায় চেঞ্জ হবে? লজিক্যাল ভিউতে চেঞ্জ হবে না ফিজিক্যাল ভিউতে চেঞ্জ হবে?
ফিজিক্যাল ভিউতে।
হ্যাঁ, লজিক্যাল ভিউ এর উপর কোনো ইমপ্লিমেন্ট হবে কি, কোনো ইমপ্যাক্ট হবে?
না।
ইয়েস। তো দিস ইজ দ্য ফিজিক্যাল লেভেল ডেটা ইন্ডিপেন্ডেন্স। তো তুমি যে লজিক্যাল যে তুমি টেবিলটা ক্রিয়েট করেছো, রাইট, দিস ইজ দ্য লজিক্যাল ভিউ, রাইট, দিস ইজ দ্য লজিক্যাল ভিউ, দিস ইজ দ্য লজিক্যাল ভিউ যেটা তুমি দেখছো when you are using the query, the select star from table name, যে সিলেক্ট স্টার ফ্রম টেবিল নেম করার পর তুমি যে একটা স্ট্রাকচার দেখতে পাচ্ছ, একটা স্কিমা দেখতে পাচ্ছ টেবিলের, তো দিস উইল নট হ্যাম্পার, দিস উইল নট চেঞ্জ, দিস উইল নট অল্টার if you alter or modify the physical schema, right? So this is physical level data independence. Okay, another one is what is the logical level data independence. What is the logical level data independence? This is the modification of the logical level without affecting the external level or the external schema. তুমি এবার তোমার ডেটাবেস, ধরো তোমার 4টে টেবিল ছিল, সেখানে তুমি এখন 5টা টেবিল করেছো বা 6টা টেবিল ক্রিয়েট করেছো, বা কোনো ডেটা ডিলিট করেছো, বা কোনো ডেটা ইনসার্ট করেছো, বা কোনো ডেটা আপডেট করেছো, so it will not hamper the external schema, right? Means it will not hamper the view, it will not hamper the view, যে আগে যে লোকটার যে যা যা ভিউ ছিল এখন সেই ভিউটা চেঞ্জ হয়ে গেছে, not like that. So restriction is still implemented and it is not affecting the restriction, তাই না? So user view does not affected by the change in the logical schema, because view is totally controlled by the DA or DBM. ভিউটা টোটালি সেট করা হয় যে কোন পার্ট অফ দ্য ডেটাবেস কি দেখতে পাবে। ক্লিয়ার? বোঝা গেছে ফিজিক্যাল লেভেল ইন্ডিপেন্ডেন্স আর লজিক্যাল লেভেল ইন্ডিপেন্ডেন্স? ক্লিয়ার? এটুকু ক্লিয়ার?
Yes, sir, clear.
জয়শ্রী কোনো কোশ্চেন আছে? অক্ষয়, শুভম,
No, sir. No, sir.
অক্ষয় আছো?
হ্যাঁ স্যার বলুন, এসছি, এইমাত্র আসলাম।
কোথায় থাকো ক্লাসের সময়?
ইয়েস স্যার।
তো ক্লাসের সময় তো বলতে পারো যে আমার ক্লাস আছে।
স্যার হঠাৎ মানে এমার্জেন্সি দরকার ছিল, চলে গেছি। ছিলাম ওই মাঝখানে 2-3 মিনিট ছিলাম না, ওই যখন বেরোলাম তখন ওই নেট চলে গেছিল পুরো।
শুভম কি আছো?
হ্যালো,
একটু ওয়েট করো, আমার কানেকশন চলে গেছে।
হ্যালো।
শুভম কি আছো?
Sir is not audible.
হ্যালো, শোনা যাচ্ছে?
Sir, you are not audible.
হ্যালো,
হ্যাঁ
শুনতে
স্যার, এবার শোনা যাচ্ছে।
শুনতে পাচ্ছ?
হ্যাঁ,
আমার নেটওয়ার্ক
yes, sir.
লস্ট হয়ে গেছে। ওকে, so I'm coming to the next part. This is the relational database. So this is the second part of the syllabus, right? So now we will deal with the relational database. This is the technical.
স্যার ভয়েস ক্লিয়ার আসছে না।
Sir, your voice is not clear. Hello, sir.
Hello.
There is some problem in network, I guess.
Just wait. We just wait for some minutes. দুটোতেই আসছে, দুটোই বন্ধ করে দাও।
ফ্যান বাড়িয়ে দেবো?
ফ্যান বাড়লে আওয়াজ আসছে।
টেবিল ফ্যানটা চালিয়ে দিয়ে এনে
Hello. Hello. Now it's audible. Hello.
ইয়েস
ইয়েস
স্যার,
স্যার,
অডিবল।
ইয়েস স্যার।
Okay. So I am coming to the next part. This is the relational database, right? So the relational database is nothing. Here we will deal with the different relation. Relation means is nothing but a table, right? The technical term, what we know actually as a table. So this is known as the relation, right? Here there is a bookish definition is there, that it is defined by the EF chord is a set of tuples where each element Ti is a member of T, capital Di, which is known as the domain. So chord's original definitions is now standing and contrary with example, whatever. So domain means what? This is the domain of ID. Means ID will, the data type of the ID is what? Is the integer. This is the domain. Suppose you have said that the ID should be from 100 to 200. Okay, so this is the domain. But all the ID will be from 100 to 200. Right? So this is the domain. And all the elements and all the, this is the set of tuples. Right? This is the tuples. Here 4 tuples are there in the relation. Okay. and each heading of the data table that already you know, these are known as the attribute. These are actually the attributes. So a table, a relation consists of different attributes, and these are the values of the attributes. Okay, so these are the value of the different attributes, and obviously uh, every tuple are uniquely identified. Means there should be one attribute. There should be one attribute which one or more than one attribute, which is known as the primary key or the candidate key, whatever, which can help to identify each tuple uniquely. Clear? This is another term which was used in this book, right, by the Caesar dates. By this book, Caesar dates actually invented that term. He has used that relation as a reliever, which is known as a relation variable. So don't be panic further. Don't afraid about this term. Right? It is the another term. Right? This is the another term which is same like relation. Right? Which is same like relation means in other book what you are known as the relation, what you are known as the table. So here the attributes are these are known as the reliever. So you don't need to remember all this, but just know this name. Reliever means is the relation variables. Right. Reliever means is the relation variables. Optimization techniques also used here. Right. Means different optimization techniques also there by which you can optimize the database. Right. What is the optimizer? This is the component of the database which used to implement the user request. Right. So different optimizations and navigation techniques are there which we will use for the different data independencies. Transactions already are there which we will use, and in transactions also we have the different features, the beginning transactions, right? If your transaction is successfully completed, then you have to commit for the transactions. Rollback is there. When a transaction will perform, so the ACID property should be uh, implemented. So these are the things that we will discuss. There is another term which has used in that book. This is the catalog. This catalog is nothing but it's all schema, right? Suppose uh, simply if you suppose you want the catalog of uh, tandoori dish, right? Or suppose the catalog of a book. But what that in short it is written, right? Catalog means what? In short, the all the product descriptions are written, or in short, the description of each item is written. So similarly, here also the catalog means where all the schemas and their mappings of the relationship are mentioned in a brief way. Right here, all the schema. It can be external schema, it can be conceptual schema, it can be the view schema, everything, and the different mappings or the different relationship. Everything is mentioned here. Right. This is the catalog. Here it is written the catalog contains the detailed information, yes, regarding the various objects that are of interest to the system itself. It can be the relation, it can be the indexes, it can be the different users, it can be
স্যার
the
ভয়েস ক্লিয়ার আসছে না।
hello,
স্যার ভয়েস ক্লিয়ার আসছে না।
hello, শুনতে পাচ্ছ? Hello,
হ্যাঁ স্যার এবার পাচ্ছি।
hello. So catalog is what? Similarly, so simply it can be the
হ্যাঁ স্যার ঠিক আছে।
it can be the relations, it can be the different indexes, it can be the different constraints, all the constraints what it use, different users, so everything written in a brief way. So this is the catalog, right? The optimizer use this catalog for the detailed information about the database, detailed information about the whole storage structure. Means if we consider about the physical storage, so it will the optimizer uses this catalog for the information. That okay, so these are the part of the database. These things are there, everything. Like when we are getting the conclusion or we are getting the knowledge by using catalog. Suppose একটা বুক আছে, সেই বুকের ক্যাটালগ দেখে আমরা বুঝতে পারি ওকে এই বুকের মধ্যে এই জিনিসগুলো আছে, রাইট? তো সিমিলারলি ইন আ ডেটাবেস অলসো একটা ক্যাটালগ থাকে যেখানে সমস্ত টেবিলস গুলো থাকে, সমস্ত ম্যাপিংস গুলো থাকে, সমস্ত স্কিমা যেগুলো থাকে সেগুলো একটা ব্রিফ দেওয়া থাকে যেখান থেকে আমরা বুঝতে পারি ওকে আর DBMS is like this, a brief structure. In a scale point of view also it is the all the schema view যেটা আমরা দেখতে পাই আমরা যখন আমরা টেবিল ক্রিয়েট করি, ওকে? So this is the catalog, like a brief introduction of the is given here, or it is one of the catalog that what is the brief descriptions of the different schema and the relationship. Or this is another catalog. দেখতে পাচ্ছ তো? This is the catalog of the sound. This is the catalog, right? So this is the brief introduction by which you can understand what the database is actually. Okay. Base relevance is what? Relevance means that I told you the relation variable. These are actually the other name of the relation, and base relevance means this is the variable which are the used. Means suppose this is the relation or this is the relevant. So these are the base relevance. This ID, name, address. So what are the value relation is contained? These are known as the base relevance. These are the term used in the used in this book or used in only this book. In that book, that the book of the database by CJ date. So these terms are used in this book only, right? Okay. So this is the next part that we will do. This is the year model. So in year model, before coming to the year model, there are total 13 rules are there, which is known as the Cox rule, and these rules implemented in year diagram as well as in when you are doing the SQL queries also, when you are creating the tables in Oracle also. At that time also you need to follow all these rules, right, said by the EF court. So what is the first rule? That for any system that is advertised as or claimed to be a relational database management system, that system must be able to manage databases entirely through its relational capabilities. Right? So what the system you want to implement means a database management system, right? So when you want to implement, or when you want to say that your system is a database management system, so that system should be manage all the databases, and it will manage all the relationship among these databases, right? So this is the basic foundation rule of a database management system. Okay, বুঝতে না পারলে কিন্তু আমাকে জিজ্ঞেস করবে। Information rule. Data stored in relational model must be value of some cell of a table, obviously. So what are the data you will store in the relational model? So that should be the part of any relational table, right? Means there should not be any data which is not part of the relational table, right? Third is what? This is the every data element must be accessible by the table name, its primary key, and name of the attributes whose value is to be determined. Right. So what are the data elements you want to access? That should be accessible by the table name or the primary key or the attribute key. Next is what null value in a database must only correspond to the missing, unknown, or not applicable values. So we will represent a variable as a null when it will be missing or it is unknown, it is not applicable values. Right. Fifth rule is what? Structure of the database must be stored in an online catalog which can be queried by authorized users. Obviously, the database should be central based, right, where all the users can access the database based on their views, right? So the database should be accessible by everything, by everyone, and from anywhere. Okay. A database should be accessible by a language supported for definition, manipulation, and stuff. Obviously, we have the SQL, right? That we are dealing with the database by a language, widely accepted language, and this is the SQL. Next is what different views are created for various purposes. Should be automatically updated by the system. Obviously, what are the views are there that should be updated based on the systems or based on the user perspective. Right? Relational model should support insert, delete, update, etc. operations at each level of the relations. Also set operations like union, intersections, minus, etc. So you can take the example of the Oracle 10G, means or the Oracle DBMS software. So in Oracle, you can implement everything. The main thing of the main concern or main say of this module is what? When you are representing a system as a DBMS, so all these features should be there. This is the main concern of the court. There should be physical level data independence. There should be the logical level data independence. Right. Integrity constraint should be there. That whatever the integrity constant we will do, whatever the integrity constant we will modify, that should not enforce the application levels. Right. You will implement all this integrity data integrity in your design level or in your logical level. Right. So that will not affect in the application levels. Distribution of the data over various locations should not be visible to end users. Obviously, where the data are stored, how the data are stored, that should not be visible by the end users. Low level access to data should not be able to bypass integrity to change the data. And there should be no one, means anyone cannot bypass all these integrity rules or can change the data. Right? There should be some authority who has only the sole permission of to change the integrity as well as to change the data. So these are the rules set by the court when a system pretend to be a DBMS. Okay, any question?
No, sir.
Hello.
Hello, sir. Hello.
हेलो, हाँ बोलो। হ্যালো,
হ্যাঁ স্যার, শোনা যাচ্ছিল না আবার।
আমি চুপচাপই ছিলাম। Okay, so next we'll start the year model.
ও আচ্ছা আচ্ছা।
So this is the entity relationship model where we will deal with the different entities and their relationship. Right? So three components are there of the year models: entity, attribute, and the relation. Right? So and there are different categories of the entity. There are different categories of the attribute. There are different categories of the relation. Right? And already you are familiar with this components. So I'm just briefly describing all this. Already you know about the entity. It can be any object, class, or person, or place, anything which have real life existence, and we representing it as a rectangle. Okay. Entity, there can be another entity which is the weak entity. Right. Weak entity means the entity does not contain any key attribute of its own, or you can say the entity which depend on another entity. Weak entity means what? If an entity is dependent on another entity, then it is known as the weak entity. Or in a fine language, if you give the definition, if an entity does not have any key attribute, then it is known as the weak entity. Here, one example is there, that is the installment, right, or EMI. So EMI means what? If you can take loan, then only you have to give the EMI, right? If you take the loan, then only your EMI will start, or you have to pay for the EMI. Otherwise, there is no option to give the installment or to give the EMI, isn't it? So this installment is totally depend on the loan entity. If your loan, if the loan entity does not exist, the installment also does not have any existence, right? If you have the loan, then only your installment will start. That's why that installment is the weak entity, and it is represented by the double rectangle. Is it clear? Jayashree, Akshay, Shubham, Annesha, Antu আছে, তাপস এসছে, তাপস নেই। Is it clear? The weak entity? Weak entity বোঝা গেছে?
Yes, sir.
Attributes. So attributes we are representing by using the as a this is the property of the entity. So these are the characteristics of the entity, right? And yeah, eclipse is used to represent that, or the oval shape is used for the this attribute. So suppose student. So what are the attribute? That can be the roll number, or that can be the ID number, right? Name, phone number, age, address. So these can be the attribute of a student. Okay, and these attributes are of different types also. This attribute you can categorize into different types. So one is the key attribute. So what is the key attribute? That I told you that key attribute is the attribute which can uniquely differentiate your entity from another entity, right? Key attribute is what? This is the attribute which can uniquely identify one entity with another entity from another entity. If you go to this example, so here ID. So first ID is of 102, second one is 202. So means this is the key attribute. Why? Because this attribute is different of each other, or you can simply say that other number, right? The other number is unique to every person. So by using the other number, or the voter ID number, one person can be uh, identifiable from another person, or one person can be segregated from another person, right? So this other number is the key attribute. Here, composite attribute is there, that the attribute which composed of any other attributes, so here in the previous example, or suppose address or this name can be the composite attribute, because that name can be the first name, M name, L name, right? Address can be the composite attribute, like the house number, right? Means you can again categorize, or you can again categorize that one entity. This is the composite attribute. Composite attribute means if you again divide the attribute into sub attributes, then it is the composite attribute. So name, this is the attribute. So you can divide the name attribute into first name, middle name, last name. Address is also there. You can divide the address attribute as a house number, road number, pin code, like etc. etc. Okay, so these are known as the composite attribute. Multi-valued attribute means what? The attribute which can take more than one value, and it is represented with a double over, like a phone number. So a person can have more than one phone number, right? A person can have more than one phone number. So that can be the multi-value attribute. Derived attribute is what? The attribute which is derived from another attribute. And this is the notation. This is the notation of the derived attribute. Either you can represent it by the dashed ellipse, or you can represent it by the dashed ellipse covered by the complete ellipse. Suppose age, right? Age. So age is derived from the date of birth. Age can be derived from the date of birth, right? So date of birth is the entity, or date of birth is date of birth is not the entity. Date of birth is the attribute, right? But age is the derived attribute. So this age is represented as a derived attribute. Clear? বোঝা গেছে এ পর্যন্ত? কোনো কোশ্চেন আছে? কারো কোনো কোশ্চেন আছে? হ্যালো, হ্যালো, কারো কোনো কোশ্চেন আছে? হ্যালো,
Yes, sir.
Yes, sir.
বলো।
Yes, sir.
Is there any question? Tell me. Any doubt, any question?
No, sir.
No, sir, no.
Okay. So this is the last slide today for today. So this is the notations of ER diagram. So that this is the relationship. Right. By this we can do the represent the relationship. If it is a dotted dashed line, then it is the one-to-one relationship. This one. This is one to many. So these branches are there. So this is the notation of one to many. Right. This is many, simply many. This is one or many. This is one or many. This is one and
Sir,
only one.
PPT was not showing.
Oh, sorry.
It's not there.
Now you can see.
Yes, sir.
এর আগেরগুলো দেখতে
Yes,
পেয়েছো?
sir.
এর আগেরগুলো দেখতে পেয়েছিলে তো এগুলো?
Yeah,
হ্যাঁ স্যার
ER
মাঝখানে
diagram, ওই যে ER diagram-এর বাদে বাকিগুলো দেখতে পেয়েছি।
হ্যাঁ ডিরাইভ অ্যাট্রিবিউট অব্দি দেখা গেছে, তারপরে আর দেখতে পাইনি।
আচ্ছা,
হ্যাঁ, ER diagram-টাই দেখতে পাইনি।
এই পর্যন্ত দেখা গেছে তো?
হ্যাঁ হ্যাঁ
ঠিক আছে, এইটা।
হ্যাঁ হ্যাঁ, এটা হ্যাঁ ER diagram.
So these are the different notations of the diagram, right, to represent the relationship. And this is one to one. The first one is representing the one to one. Second one is this is one to many. That one vertical bar is representing one, and that lines are representing as many. So this is the one to many notation. This is simply many notation. That can be the many to many, that can be the many to one, whatever. This is one or more, one or many. Yes. If you see this type of symbol, so this is known as the one or more, like that, employee and company. I am coming to this point. This is one and only one. This representing is one and only one. This is 0 or 1. This is representing 0 or 1, and it is representing 0 or many. Right. So these are the notations. So now here the diagrams are there. That project is there. Three entities are there: project, employee, and company, and the relationships are there. So here you can see the projects and employee. So project to employee is what? This is 0 to many. Right. And employee to project is what? This is one or many. Right. Means, so our employee can have 0 project or more project. Fine. Many employee can have 0 project or can have many projects. A project can have one employee, or a project is assigned to many employees. Is it clear that this relationship? An employee can have 0 project. Suppose the employee does not have any project, or the employees does not have any project. So this is many to 0. Right. Employees have more than one project. So this is many to many. Or one employee has many projects. So this is one to many. Clear? This is the relationship. Similarly, employee to company. So one employee can be the under one company. Many employee can be under one company. So by this way, you can represent the ER diagram. So this is the notation. Any doubt?
No, sir.
ওকে, আজকে তাহলে এই পর্যন্ত থাক। কোনো কোশ্চেন থাকলে বলো, এর আগে পর্যন্ত যা কিছু হয়েছে। কোনো ডাউট থাকলে বলো এই পর্যন্ত। যদি কোনো অন্য কোনো কিছু কোশ্চেন থাকে বলতে পারো। তোমাদের আগের দিনের অ্যাসাইনমেন্ট তোমরা দিয়েছো, তাই তো?
হ্যাঁ স্যার।
তোমরা গ্রেড পেয়ে গেছো? গ্রেড পাঠিয়ে দিয়েছি।
হ্যাঁ হ্যাঁ।
আচ্ছা, দেখছি।
স্যার আগের দিনে 5টা কোশ্চেনের মধ্যে 4টে অনলি ভিজিবল ছিল।
ভিজিবল ছিল?
একটা কোশ্চেন আমি দেখতে পাইনি।
5টাই তো ভিজিবল থাকার কথা।
হ্যাঁ স্যার, একটা অপশন 1 ছিল।
স্যার হ্যাঁ,
একটা অপশন শুধু 1 ছিল।
অপশন 1 ছিল।
দাঁড়া এক সেকেন্ড দেখে
হ্যাঁ,
নিচ্ছি।
আর কিছুই ছিল না।
দাঁড়া এক সেকেন্ড। একটা
এই যে কোশ্চেন অপশন 1।
আচ্ছা আচ্ছা আচ্ছা, 4টে কোশ্চেন ছিল না? ঠিক আছে, ওটা আমি চেঞ্জ করবো। ওটা আমি চেঞ্জ।
স্যার একটা কোশ্চেন ছিল সেখানে ওটা মানে ওই যে পোর ইন্ট্রিগেটিটা বলে
বলো।
উত্তরটা নেই না, মানে এটা পড়ে না।
বুঝতে পারছি, আরেকবার বলো, কেটে কেটে দিও। আসছি কোশ্চেনের মধ্যে।
স্যার বলছি কোশ্চেনটা।
আমি বের করছি, আমি গ্রেডটা বের করব। বলো কোনটা? এইটা disadvantages of file
কোশ্চেন ছিল
systems
না
are হুম
খুঁজে পাচ্ছি না কোশ্চেন।
disadvantages of file systems are, ওটাই তো।
ডেটা রিডান্ডেন্সি, ওই যে
হুম, হুম।
কোশ্চেনটা।
এই তো আমি বের করেছি, দেখো। Wait, can I see it? হাই কোশ্চেনটা বলো। হ্যালো, এই কোশ্চেনটা তো disadvantages of file system is or are।
হ্যাঁ, ওটা কোর ইন্টিগ্রিটিটা পড়ে না স্যার?
পড়ো তো। এক সেকেন্ড দাঁড়াও দাঁড়াও, কোশ্চেন
কিন্তু
এখানে
অল অফ,
এখানে মানে 2 মার্কস দেওয়া ছিল না এটা? ও তাহলে তো মানে ঠিকই আছে। একটু দাঁড়াও তো, আমি দেখে নিই। 4টে কোশ্চেনই আমি দিয়েছিলাম, একটু ওয়েট করে। গ্রেড ঠিকঠাকই ছিল তোমার। হ্যাঁ এটা তো, এই কোশ্চেনটা বেসিক্যালি আমার হয়ে গেছে। এই যে কোশ্চেনটা যেটা ছিল না, এখানে দুটো
হ্যাঁ
কারেক্ট তো, প্রথমটাও কারেক্ট, সেকেন্ডেরটাও
হ্যাঁ
তো কারেক্ট।
হ্যাঁ হ্যাঁ হ্যাঁ, আমি সেটাই বলছি, তাই জন্য আমি অল অফ দিস পড়ে গেছি, কেন কোর ইন্টিগ্রিটিটাও তো পড়ে না।
ডেটা ইন্ডিপেন্ডেন্স তো পড়ে না।
না, তো ওটা মানে তাও বুঝতে পাইনি সেটা,
এটাতে
তাই অল অফ দিস করে দিয়েছি।
এটাতে 2 মার্কস ছিল, ওই জন্য 5 মার্কস হয়েছে। লাস্টের কোশ্চেনটা ওটা মানে নেই, টোটাল 4টে কোশ্চেন দিয়েছি, 5 মার্কস। ঠিক আছে।
মানে দুটো ক্লিক করা যায় তো, দুটো অপশন?
হ্যাঁ এটা দেখো, তোমার করা তো, চেক বক্স দেওয়া ছিল।
ও আচ্ছা আচ্ছা, মানে এরকম হতে পারে যে দুটো যদি বা তিনটে ঠিক হয়, তিনটেও ক্লিক করতে পারবো।
হুম,
আচ্ছা, আমি বুঝতে পারিনি।
চেক বক্স থাকলে তুমি করতে পারো।
ওকে।
ওই জন্য ওটা তোমার 58333 করে আছে। ঠিক আছে, আগার তাহলে কোনো কোশ্চেন আছে? তাহলে শেষ করবো।
না স্যার।
ঠিক আছে, ঠিক আছে, আমি এন্ড করছি।